Hello and welcome to the ath-OS channel in English. Recently I saw on Twitter some automatically generated formula about binomial coefficients, which looked like this. Pretty nice, isn't it? Then someone asked the right question. Yes, but why? So I decided to produce a short video providing a complete solution to that question. As you'll see, it's all about undergraduate mathematics, but I think it's well worth a visit. Consider S sub n, which denotes the sum for k equals 0 to n of -1 to the kth power multiplied by n choose k squared. The key idea is that S sub n can be considered as the coefficient of x to the n in the expansion of the following polynomial. P sub n equals 1 minus x to the n multiplied by 1 plus x to the n. Indeed, that coefficient appears at first glance to be the sum for k equals 0 to n of -1 to the k multiplied by the product of n choose k by n choose n minus k. But we know that binomial coefficients are symmetric, which means that n choose k and n choose n minus k are exactly the same. On the other hand, we obviously have p sub n equals 1 minus x squared to the n, and using the Newton's binomial theorem, we see that p sub n can be written this way. Comparing both expressions leads finally to the following conclusion. S sub n equals 0 if n is odd, and otherwise -1 to the n halves multiplied by n choose n halves. And at the special case, replacing n by 2n, we get s sub 2n equals -1 to the n multiplied by 2n choose n. The last thing remains to be done, namely multiplying both sides by -1 to the n, and now we obtain the desired formula. By the way, this formula gives us an unexpected expression for the nth central binomial coefficient. Okay, that's it for today. Maybe you liked this little calculation or at least found it useful. In that case, please leave your comments below. And I hope that we'll meet again very soon on this channel.